We start with the topic of the derivative. Let's start with the definition of a slope or the gradient of a tangent to a curve at a given point x f of x. And that is given by the limit of f of x plus h minus f of x all divided by h as h approaches 0. This limit is defined as the derivative of f of x at the point x. And the process of trying to find this derivative of x with respect to x is called differentiation. And please note that the derivative with respect to x is given by d over dx, or sometimes the capital letter D with subscript x. Therefore, we can then be able to say f prime of x, which is the derivative of f of x over dx, is given by the limit that we had said is the slope or the gradient of the tangent. Now let's do some examples using the definition. The first question requires us to determine the derivative of f of x, which is equal to 2x squared plus 3x. The solution is given by df over dx on the left-hand side equal to the limit, straight from the definition of the derivative. And then what we do, we substitute for f of x plus h, wherever there is x into x squared plus 3x, we substitute x plus h. Hence, I have here 2 into x plus h all squared plus 3 into x plus h minus f of x as it is. Note I've put f of x in brackets because it's got 2 terms. So minus, then put 2x squared plus 3x in brackets. Note that all of this is still divided by h, and also remember we're taking down lim as h approaches 0. And then thereafter, again in the next step, limit as h approaches 0 is still there. And then we simplify our numerator, taking away all, or should we say removing all the brackets. So I've got 2x squared. Please check whether my calculations are correct. Plus 4xh plus 2h squared for the first term. Plus 3x plus 3h. Then I remove the brackets for f of x. So therefore I've got minus 2x squared minus 3x. All of this is divided by h. And then thereafter, again, I simplify further. I notice that 2x squared and minus 2x squared, they cancel. 3x and minus 3x, they cancel. So therefore, I'm left with 3 terms in my numerator, which is 4xh plus 2h squared plus 3h. All of this is divided by h. And note, I still have lim as h approaches 0. In my numerator, I see that there is a common term, which is h. So I take it out. If we take it out, and then h and h in the denominator will cancel out, leaving the limit as h approaches 0 of 4x plus 2h plus 3. Thereafter, substitute the value of h into the expression. Therefore, that derivative becomes 4x plus 3. Please note, immediately you've substituted h is equal to 0. You can't write lim again. And note again, we could not substitute h equal to 0 in all the other expressions because we had an h in the denominator. So therefore, we have to find a way to eliminate that h from the denominator before we substitute the value for h equal to 0. Because remember, in mathematics, we cannot divide by 0. We go to the next slide. Example 2 is f of x equal to 4x cubed plus 5 over x. Again, the solution. Bring back the definition. You need to start by writing down the definition of the derivative. Even on your left-hand side, you can choose to write df over dx as I've written, or just simply write f prime of x. It's still okay. Note once more, wherever there is x in f of x, we substitute x plus h in order for us to get the first term, which is f of x plus h. So that means I'll have 4 into x plus h all cubed. That's the first term. Plus 5 over x plus h, which is the second term of f of x. Note, in place of x, I substituted x plus h. Minus. Note again, f of x has got 2 terms. And because of that, I have to use a bracket when I substitute f of x. So that means I have minus the bracket f of x cubed plus f over x. And I still have that division by h. And please note that I still have the limit written down as h approaches 0. Now what I need you to do for me, I need you to simplify that numerator. Take a pen and paper, simplify that numerator, remove all brackets, and cancel all terms that need to be cancelled, and make that whole expression under one common denominator. And check for me whether what I've written here is the answer after simplification. I have 3 terms in the numerator left, divided by h. 12x squared over h plus 12x h squared plus 4h cubed. And then I've got minus 5h all divided by hx into x plus h. I say this again. Please confirm whether this step is correct. And once more note, in that numerator for the first term, h is common. So if you take out h and h cancel, then you'll be left with 12x squared plus 12xh plus 4h squared in the first term. So please make sure that you fill in the missing steps. Minus, I still have the h and h will cancel, and then we'll be remaining with 5 over x into x plus h. And then thereafter you substitute h equal to 0. Please confirm that you will get 12x squared minus 5 over x squared. Please do this so that we can all get it right. Next, f of x is equal to the square root of x. That's example 3. Again, once more, first thing we do is to write down the definition of our derivative. The next step, substitute for f of x plus h, which will be the square root of x plus h. And then minus, we substitute the original function, which is square root of x. All of this is divided by h. Note that even if we try to simplify this expression, it's not possible unless we do rationalization. And again, note we cannot substitute h equal to 0 because we have an h in the denominator. We'll end up dividing by 0. So we need to rationalize the numerator. And I hope you still remember that we'll change the sign between those two terms. So you had square root of x plus h minus square root of x. That means you'll be multiplying by the square root of x plus h plus the square root of x divided by square root of x plus h plus square root of x. So all in all, you're just multiplying by 1. And then now I need you to confirm. After multiplication of those two in the numerator, do we really get 1? Because I got a 1 in that numerator. Please do your multiplication and let's see whether you'll get 1. And then in the denominator, we have just the square root of x plus h plus the square root of x. Is this true? And then remember, we still have not substituted h equal to 0, so we take down that limb as h approaches 0. And then we substitute 0 in, and I'm left with 1 over 2 square root of x as my answer. Now we go to the rules of basic differentiation. Remember, in the previous slides, we were using the definition of the derivative, which is the same as finding the gradient or the slope of a tangent. Now, we're using the rules of differentiation given in the table that I've attached here. One of the first rules of differentiation is that the derivative of a constant is equal to 0. Therefore, number 1, which is given to be y equal to the square root of 3. Square root of 3 is just a number which has got a value that's 1 point something. So therefore its derivative is equal to 0 because square root of 3 is just a constant. And then we go to the second one. Number 2 includes rules 2 and 3. Rule 2 says the derivative of c times x is equal to c. At the same time, the derivative, number 3, the derivative of x to the power n is nx to the power n minus 1. So therefore, we can find the derivative of that function given to us, which is a polynomial, in number 2. So y prime, for x to the power 4, the derivative would be 4x cubed. And note in our answer, we take down the sign, and then 2x squared. Remember, you take 2 out and find the derivative of x squared, and the derivative of x squared is 2x, and 2 times 2 will become 4. That is why we have minus 4x here. And then the last term is plus 2, and the derivative of a constant is what? It is 0. Hence, our answer is just 4x cubed minus 4x. Example 3 has been given to us as x squared plus e to the power negative 3x squared. Now note that the second term is an exponential function. Now let's go to the first term. The derivative of x squared is 2x. Now we go to the second term. The derivative of an exponential function is the exponential function. But then you multiply that exponential function by the derivative of the power. The derivative of negative 3x squared is negative 9x squared. Hence, we have here 2x minus 9x squared multiplied by the given exponential function. Remember, the derivative of e to the power x is e to the power x. The derivative of e to the power 2x is 2 e to the power 2x. So therefore, when we go to number 4, we have y equal to 12 over x minus 4 over x cubed plus 1 over x power minus 4. Note that our variables are in the denominator. So the first thing you do, bring them up to the numerator so that we can be able to use the first 3 rules of our table. Then, because we're dividing by x and the power of x was 1, when you take it up, it becomes negative 1. So you've got the first term as 12x power negative 1 minus 4 times x to the power negative 3 plus. Note that when you take x power negative 4 up, the power changes to be a positive sign. So hence we have x to the power 4. Therefore, the derivative of this function for the first term, it would be, remember, we take that power and multiply it to the 12. So it becomes negative 12. X to the power minus 1 minus 1, which becomes minus 2. When you take it down, it becomes x squared. Therefore, you have minus 12 over x squared is the first term. Well, let's go to the second term. We take negative 3, which is the power of x, make it the coefficient. So we multiply it to that negative 4, making a positive 12. And then the power of x, when you do differentiation, you subtract by 1. Therefore, it becomes x to the power negative 4. And when you take it down, it becomes x to the power 4. And then we know the derivative of x to the power 4 is 4x cubed. Please note that we have to write the answer in the format of the original function. That is why we don't leave it with negative powers. We take those variables to the denominator to make sure that they have positive exponents. Let's go to number 5. Number 5, y is equal to sine x plus cos x divided by cos x. Now we're going to the different derivatives of transcendental functions, which are just trigonometric functions actually. So the first thing we need to do here, because we have not been even introduced to how we find the derivative of quotients. Therefore, the first thing we do here, simplify. So it means multiplying each term by cos x. When you multiply sine x by cos x, you get 10x. When you multiply cos x by cos x, you get 1. And therefore, we know that expression is 10x plus 1. And then find the derivative. What you know, the derivative of 10x from the tables is sec squared x. And the derivative of 1 is 0. Example 6. Y is a product now of two functions. Then we use what we call the product rule, which we find also in our tables. What it simply means is that we've got two functions here, the first bracket and the second bracket. First things you do, find the derivative of the first bracket. First derivative of the first bracket, it gives us 4x cubed minus 6x, because the derivative of 3 is 0. Put that in brackets and you take down the second bracket as it is, plus. Now you take down the first bracket from the original function as it is and find the derivative of the second bracket. The derivative of 1 is 0 and the derivative of x cubed is 3x, but then you have a negative 2 there. So it's negative 2 times 3, giving us negative 6x squared. Let me repeat this again. We use the product rule here. The product rule says take down first the second function and find the derivative of the first function. So you're multiplying the second function by the derivative of the first function, plus the first function as it is multiplied by the derivative of the second function. So even if you can interchange these two, it doesn't matter. You may start by taking down the first function and find the derivative of the second, plus the second function times the derivative of the first. It doesn't matter. The answer will always be the same. Now, again, going to the derivative of a quotient. You cannot simplify that, or it is possible if you could be able to see that e squared is just a number that you can find on your calculators. But for now, let's do the quotient rule. Now let's note that the quotient rule says, first thing you need to do is to take the denominator up as it is. Take the denominator up when you do your differentiation, and then multiply that by the derivative of the numerator. As you can see, I took 3x squared minus 5x up, put it in bracket, and then multiplied by the derivative of e squared. Note e squared is just a number that you can punch in your calculators, and it is 0. And then you subtract the numerator as it is, multiplied by the derivative of that denominator. And the derivative of 3x squared is 6x, minus the derivative of 5x, which is 5. Then all of this will be divided by the denominator squared. Let me do this again. When you are given a quotient and you want to use the quotient rule, first things first, denominator up, multiplied by the derivative of the numerator, minus the given numerator times the derivative of the original denominator. All of this is divided by the denominator squared. Let's go to number 8. Let's re-emphasize this point of the quotient rule. As you can see, this is a quotient and you cannot simplify it. So, rule of the quotient rule says, when you're trying to find the derivative of a quotient, denominator up first. So we take 4x plus 3 up, multiplied by the derivative of the numerator. So 2x cubed gives us 6x squared, minus the derivative of x squared gives us minus 2x, and the derivative of minus 2 is 0. And then we have minus that original numerator multiplied by the derivative of the original denominator. That's why we have 2x cubed minus x squared minus 2 into 4. Note the derivative of 4x plus 3 is just 4. And all of this is divided by 4x plus 3 all squared. Note denominator up times the derivative of the numerator minus the numerator times the derivative of the denominator. All of this is divided by 4x plus 3 all squared. Once more, I'm bringing in now the derivative of the square root sign. The derivative of x is 1 over 2 square root of x. I believe that we had done this using the definition, and our answer was 1 over 2 square root of x. Note that if under the square root sign you don't have x, but you have a function of x, then it means the derivative of that function under the square root sign goes to the numerator. Hence, you'll have f prime of x divided by 2 square root of f of x, the original function. Now let's put this into practice as we go to example 9. We have here y is equal to the square root of 1 plus cos 2x. Note, 1 plus cos 2x is a function of x, so we need to know the derivative of that function. Derivative of 1 is 0. The derivative of cos is minus sine, and the derivative of 2x is 2. Hence, we have minus 2 sine 2x in our numerator, which represents f prime of x. That means the derivative of the argument of that square root. And we know the derivative of a square root is 1 over 2 square root, whatever the function is under the square root sign. Hence, we have 2 over square root of 1 plus cos 2x in the denominator. And to represent that this is a function, we know that its derivative is the one you'll find in the numerator. Number 10, we're using all these rules, as you can see. Quotient rule. Now we're introducing 10 squared in our numerator. 10 squared, 3x, all divided by 2 plus sine x squared. Quotient rule, okay? Denominator up first to find our derivative for 2 plus sine x squared. That's our denominator. Into the derivative of that numerator. Now, the first thing I did was to find the derivative of that power. Hence, I said this is just 2, 10, 3x. 2, 10, 3x, because I know the derivative of x squared is what? Is 2x. So I treated it like that. That, okay, this is 10 squared, 3x, so it must be 2, 10x. Now, note, I've not yet differentiated 10. That is why now I come back to differentiate 10, 3x. 10, 3x, remember I started with the power. That's why it's 2, 10, 3x. Now we have to go to 10, 3x and find the derivative of 10. My table say the derivative of 10 is sec squared. So hence I've got sec squared 3x. Note the argument of 10 does not change. But then I don't have 10x there. I have 10, 3x. So I have to include the derivative of the argument of 10. Hence we've got 3 sec squared 3x. Once again, I said we take the denominator up, and then in trying to find the derivative of 10 squared 3x, the first thing you consider is the power. Hence the derivative of a function squared is 2 times that function. Hence I've got 2 times 10x multiplied by the derivative of 10, 3x, which is sec squared 3x multiplied by the derivative of 3x, which is 3. Hence I've got 3 sec squared 3x minus the numerator as it is, because this is a quotient rule, into the derivative of the denominator. Note that the derivative of 2 is 0. And then we come here. The derivative of sine x squared. The derivative of sine is cos, so I'll have cos x squared. But then I don't have x here, it's x squared. So the derivative of x squared is what? Is 2x. So I must write 2x cos x squared. All of this is divided by the denominator squared. Once more, another rule that includes logs in our tables. Number 11, we have now our function is log of 1 minus 3x base 2. The derivative of this is the in the numerator, you have the derivative of the argument of the log. So the derivative of 1 minus 3x is minus 3, divided by. In the denominator, you have the argument of the log as it is 1 minus 3x. All of this is multiplied by ln of the base. I'm hoping you are with me. We say the answer to the derivative of log of 1 minus 3x base 2. Firstly, in the numerator, is the derivative of the argument of the log. So it's the derivative of 1 minus 3x, which is minus 3, divided by. In the denominator, you have the argument as it is, 1 minus 3x. All of this is multiplied by ln of the base of the log. Okay, now let's go to the next example, number 12. Y is equal to cos ln x. Ln x, its derivative is 1 over x. So, which means when we do this derivative of cos ln x, the first thing we have to recognize that the derivative of cos is what? Is negative sign. So you have negative sign ln x because ln x is the argument of cos. So we've got minus sign ln x multiplied by the derivative of ln x, which is 1 over x. So I just wrote it as minus sign ln x all divided by x.